So we're going to talk about 9.3. We need our calculators out. Number 2, we're going to be dealing a 5-card hand from a standard deck. And as I mentioned in class, if you are not comfortable with a deck of cards, I was hoping that today would be the day we'd spend some time on that, but since we don't have class, you'll need to spend some time with a deck of cards on your own if you're not familiar with the basics. So here we go. How many 5-card hands are possible? There are 52 cards in the deck. So the total number of hands, this is question A, would be 52C5. And I believe that we had typed that number in. I can't remember, so we'll do it now. 2,598,960. That's how many hands are possible. Different hands are possible in the deck. So as we are doing our probability problems, notice that every single one of the questions on this page has to do with that 5-card hand. So every single one of these will have that as its denominator. Now I am writing 52C5 because it is easier than writing that big number over and over and over again. But every denominator will be that number for every single problem on this page, because that's the total. And when we do probability, it's the chances out of the total. So the total is that. So how many are there? So every one of these problems, we are going to be either retyping 52C5 or typing in that number for every single answer. All right, so what are the numerators? That's the denominator for all of them. What are the numerators? Well, the numerators aren't the total. The numerators are what you want to have happen. So for problem B, we want all diamonds. Well, the deck has 13 diamonds. So for my numerator, I'm not picking from 52, I'm only picking from 13 because I need to get all diamonds. So there are 13 diamonds. I'm going to pick 5 of them. And then my total is all 52, pick 5. So 13C5 divided by, either type 52C5 or type in that number. It's completely up to you. It doesn't make any difference. Your calculator will handle it. Do be careful when you get your answer though, because it's times 10 to the negative 4th. Pay attention. These probabilities are small, so it's not uncommon at all for them to go into scientific notation. This one did, times 10 to the negative 4th. So your actual answer is, I can move that decimal point 4 places, so 0.000495,198. That's my probability. Very, very small. Do not bet your allowance on getting an all diamond hand. Probably isn't going to happen. All right, what about the probability of being dealt a hand with all face cards? Well, again, the denominator is the total. There are 52 total cards. You're picking 5 of them. The numerator is face cards. Now remember, face cards are the cards with faces on them. So you have a jack, a queen, and a king of clubs, of spades, of hearts, of diamonds. So there are 12 face cards, and you're going to pick 5 of them. You want all 5 to be face cards. So you're picking all 5 out of the face card pile, not the total pile. The denominator is the total pile. Okay, so I'll type this in. I get an even smaller number, 3.04737 times 10 to the negative fourth. So that's 0.00304.7. Very small numbers, very small probabilities. All right, all red. Again, this is the total on the bottom. How many red cards are there in the deck? Well, half the cards are red, diamonds and hearts. So 26, C5. Do not try to reduce that and say, oh, that looks like it's 1/2. No, 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 no. That does not reduce. You cannot cancel. You need to type it in. So 26 C5 divided by 52 C5. 0.0253. So in other words, your chances of getting an all red hand are about 2%, 0.02, 2.5%, 0.025. 3 jacks and 2 kings. So again, here's my denominator, problem E. I want 3 jacks and 2 kings. Well, how many jacks are in the deck? 4, 1 of each suit. And there's 4 jacks and I want 3 of them. So that's going to be 4C3. 4 jacks total, picking 3. And times 2 kings, 4C2. So this time, it's kind of like the problem we did the other day where we had boys and girls. Now we have jacks and kings. And we're picking 3 from the jack pile. There's 4 cards in the jack pile, 4 jacks. I'm picking 3 of them. And times, I'm picking 2 kings. Your calculator will do that if you just type it in. So if you just type 4C3 times 4C2 divided by 52 C5. Made a mistake. Pressed the wrong button. I'll have to start all over again. So 4C3, sorry about that, times 4C2 divided by 52 C5. 9.23446 times 10 to the, oh my gosh, -6th. That is a very small number. 0.000009234. Wow. Yeah. Very, very, very tiny number. F, no face cards. No face cards. Well, remember, we had another problem over here somewhere where we counted up 12 face cards. 3 of them from diamonds, 3 from clubs, spades, hearts, 12. So if there's 52 cards in the deck and 12 of them are face cards, then 40 of them aren't face cards. And those are the ones I want to pick. So 40 C5. So one more time, where did the 40 come from? There's 52 cards in the deck, and 12 of them have faces. So that means there are 40 of them that don't have faces. and I want to pick 5 cards with no faces, so I'm going to take that 40 and pick 5 out of there. So 40C5. And that will be, it's going to be a bigger number than we've had so far. I keep pressing that wrong button. I don't know what's wrong with me. So 40C5 divided by 52. C5. 0.25318. That means that there's about a 25% chance, 1 in 4, that you're going to get a card with, or a hand with no face cards. So basically, if I had 4 of you in here and I gave each of you a hand, 1 of you would have no face cards. The rest of you would. A 5-card hand having all of the aces. All of the aces. Well, how many aces are in the deck? 4. And you want them all. That's 4C4. There are only 4 aces in the deck, you guys. And you need them all. So there are my 4 aces. I got to have them all 4 of them. Now, here's the tricky part of the question. You are supposed to have 5 cards in your hand. We know 4 of them are aces. What is the other one? Something else that's not an ace. Well, if there's 52 cards in the deck and 4 of them are aces, how many aren't aces? 48. And you have to pick one of those 48. You have to pick one of those 48 cards to go with your 4 aces. Because you got to have 5 cards. And there's only 4 aces. So you got to pick another one. So there it is, 48C1. That's some other card, not an ace, because they're already out. They're over here. There we go. So that one is 1.84689 times 10 to the negative 5th. Another really small number. So 0.000184689. Yep, right there it is. All right, here we go. We want 2 10s, 2 jacks, and 1 queen. 2 10s, 2 jacks, 1 queen. Well, there are 4 10s in the deck. I'm going to drop that down a little lower. I'm afraid you can't see it up there. So this is H. So there are 4 10s in the deck, and I want 2 of them. So right there's my 10s. 4 10s to choose from, and I'm picking 2 of them. And 2 jacks. There's 4 jacks. I'm picking 2 of them. And 1 queen. There's 4 queens, and I am picking 1 of them. So again, your basic familiarity with the cards is important. We have 4 jacks, 4 10s, 4 queens, and I want 2 of the one, 2 of this one, and 1 of that one. So here we go. 4 C2 times 4 C2 times 4 C1 divided by 52 C5. 5.54068 times 10 to the negative 5th, 0.0000554. last one. I want a 5-card hand. No aces, no queens, no fives. So here's my deck of cards. I'm going to take, there's 52 of them, 52 of them. I'm going to take out all the aces, all the queens, and all the fives. So how many cards have I taken out? There's 4 of each. So I've taken out 12. I had 52 to start with. I'm pulling out 12 of them because I don't want those 12. That leaves me with 40. So I think we already did this answer. It will be the same. It was a different question, but the answer will be the same. 40C5 over 52C5. All right. So far we've talked about the probability with the tables, the M&M problems, remember? We've talked about now the probability with the cards, which is all based on combinations. It's just all combinations. Everything we did up here is a combination. Now we're going to talk about probabilities with a Venn diagram. Now you have, I'm sure, studied Venn diagrams at some point, whether it was math class or science class or something. You know that a Venn diagram is made up of overlapping circles. So for example, somebody has surveyed 30 kids, asked them what kind of candy they liked, and the tally looked like this. So some of them like M&Ms, some of them like Twix, some of them like both, maybe some of them don't like either, I don't know. But there is our Venn diagram. It shows us the different regions where these kids fell. All right, so first question. How many like M&Ms? The answer to question A, how many like M&Ms, is 17. Why is it 17? Because the M&M ball, everybody inside the M&M ball likes M&Ms. Everybody in there likes M&Ms. There are 17 kids inside the M&M ball. Now, how many like only M&Ms? Well, that's a different question. If you like only M&Ms, then you're inside the M&M ball, but not inside the Twix ball. So that would be these 11 right here. Those 11 like only M&Ms. How many like both? Well, the ones that like both are where the circles overlap. Those 6 kids are inside the M&M ball and the Twix ball. How many like M&Ms or Twix? Now don't get confused. There are 26 kids who like M&Ms or Twix. Think about this for a second. I got my 30 kids out here. How many of you like M&Ms? 17 hands go up. So there's 17 kids out there that like M&Ms. I said, okay, now leave your hand up. Now, how many of you like Twix? Well, 9 more hands go up. So now how many hands are up? 26. E. How many like only M&Ms or only Twix? You see the difference between questions D and E? We've been talking about all along that every one of these problems is a word problem and you have to read it very carefully. So how many like only M&Ms or only Twix? Well, that would be 20. How many don't like either one? second. How many kids are in the class? 40. How many hands went up? 26. So that means there's 4 kids out here. They're not in the M&M circle. They're not in the Twix circle. But remember, they're in the classroom. I got 30 kids in my box. I've got 26 in the balls. So there have to be 4 outside that don't like anything. All right, question 4. Now you're going to draw your own Venn diagram. So we like jazz and country, and then these guys right here like both. There's 28. Everybody likes something. So there's nobody out here. There's nobody out there. Everybody likes one or the other. How many students like only jazz? Now, what do we know? We have 18 students that like jazz, and we have 14 students that like country. Oops. Now, if you got your thinking cap on, if you're not just fast forwarding through this lovely video, you notice something about this problem. I don't know if I'm missing a page or not. Anyway, there's something going on here. What's the problem? We have 28 kids in the room. But when I ask for a vote, 18 jazz hands went up and 14 country hands went up. You see a problem? That's 32. If there's only 28 kids in the class and 32 hands went up, then what happened? 4 people voted twice. So we got 4 right there in the middle. 4 people voted twice. I think I am missing a page. I'm gonna have to figure that out. I'll get back with you on that. But we're gonna go ahead and finish these anyhow. So 4 people voted twice. Voted for both. They like both kinds of music. Now remember, the jazz ball has a total of 18 people. Now 4 of them are here, so there must be 14 more here. 18 total. And this one has 14 total, so this must be 10. Now if you look, 14, 4, and 10, that gives you your 28. Everybody's accounted for. So how many like only jazz? The question was, how many students like only jazz? That would be these guys right here, 14, like only jazz. All right, I'll have to run off that other page and give it to you, but we're gonna go ahead and move on to number 7. There's a couple more Venn diagram problems we need to do, but you don't have them, I don't have them, so we're just moving ahead here. Number 7. Now, okay, first of all, let's back up. We had the probability questions with the M&Ms where you were given a table. We had the probability problems with the cards where you were doing combinations, 52C5. We have these with the Venn diagram. And finally, we have this last kind. Notice there's no chart with M&Ms or something. There's no cards. There's no Venn diagram. So this is a different kind. These are going to be these are what we call your conditional probability problems. These are going to be a tree diagram. We'll see how that works in just a second. If it rains tomorrow, the probability that Joe will do his homework is 40%. If it doesn't rain, the probability of doing the homework is 10%. Given that the probability of rain tomorrow is 30%, find Joe's probability of doing homework. So this is called conditional probability, because whether Joe does his homework or not depends on whether it rains. So there's a condition. Does it rain or not? And that's how Joe decides whether he's going to do his homework. All of our tree diagrams will have two levels, two steps. The question that's being asked is always the bottom level. So my two levels, my two things in this problem are rain or not rain, and homework or not homework. Since the question says, find the probability of doing homework, homework is going to be second. First is going to be, is it going to rain or not rain? Okay, so that's where we're starting. Is it going to rain or not rain? Okay, now, second level is he going to do homework or not homework? Is he going to do homework or not homework? So, first step is rain, second step is homework, because the question ultimately is find the probability of doing homework, and that is always the bottom. All right, so what do we know? If it rains, the probability he'll do his homework is 40%. So I'm going to put 0.40, 40%. Now, boys and girls, that automatically means that this is 60. Because it's either going to rain or it's not going to rain, and that adds up to 100. If it doesn't rain, oh, wait, I'm sorry, I put that, those in the wrong spot. If it rains, the probability he'll do his homework is 40. The probability he won't do his homework is 60. All right, so let me back up. If it rains, so we're on this branch, I don't know what that probability is, but if it rains, he's going to do homework 40%. If it doesn't rain, then, if it rains, then there's a 60% chance he won't do his homework. So if it rains, the probability he'll do his homework is 40. That means this is 60. If it doesn't rain, the probability of his doing his homework, no rain, doing homework is 10. That means this is 90. The probability that it will rain tomorrow is 30%, which means this is 70%. All right, so let's make sure we got all those numbers since I kind of messed up there. So if it rains, the probability he'll do the homework is 40. That makes this 60, because the little V thing, the branch there, is always going to add up to 100. If it doesn't rain, the probability is 10 that he'll do his homework. So not rain, homework is 10. That makes this 90. The probability of rain is 30, which means that is 70. Find the probability of doing homework. So in other words, we want to find the probability of here and here. Those are my homework branches of the tree. This branch, start at the top and get to here. So you got a 30 and a 40. So this is rain and homework. So 0.30 times 0.40. Rain and times homework. Or we can have not rain and homework. So there's two ways Joe's going to do his homework. He's either going to do his homework on a rain day, or he's going to do his homework on a not rain day. So I'll just multiply those together, add them up, and that will be my answer. .19. So there's a 19% chance that Joe is going to do his homework. All right, let's look at the next one. What are we trying, what's going on in this problem? What are the two things that are happening? Serving noodles and serving salad. Serving noodles, serving salad. All right, let's look at the question. Find the probability that they will serve salad. So that means salad is on the bottom. So I'm going to start with noodles and no noodles. That's the beginning. And then I'll either have salad or no salad. Remember, the bottom row of the tree, this bottom line, is always what the question is. So there's a lot of numbers, there's a lot of words in the problem, but you have to read all the way through. The question is salad. Okay, so if the cafeteria serves noodles, so here we are at noodles, there is an 80% chance we'll do salad, which means there's a 20% chance we won't. If they don't serve noodles, there is a 50, so no noodles, there's a 50% chance they serve salad. Given that they serve noodles once each school week, so that's 1 out of 5 days, 1/5, 20%. 20% chance of noodles, 1 day out of 5. Then there's an 80% chance of no noodles. Find the probability they will serve salad. So I need this branch, a salad branch here, and a salad branch here. So here we go. 0.20 times 0.80, that's that branch. Or 0.80 times 0.50, that's this branch right here, 0.80, 0.50. So remember, noodles and salad is multiply, or no noodles and salad, so we're going to add those. So 0.2 times 0.8 plus 0.8 times 0.5, 56%. There's a 56% chance they will serve salad. All right, one more. Hope this thing's still running here. Yep. The probability that a student plays lacrosse, if he plays soccer, is 62%. The probability. Okay, so what's happening in this problem is lacrosse and soccer. All right, so I got to set up my levels. I got to know which one goes on top. Find the probability of playing lacrosse. So that's going to go on the bottom. So I'm going to start with soccer and no soccer. And then I'm going to have lacrosse and no lacrosse. The probability that a student plays lacrosse if he plays soccer is 62%. So if he plays soccer, then there's a 62% chance he does lacrosse, which means there's a 38% chance he doesn't do lacrosse. The probability that he plays lacrosse if he doesn't play soccer, so no soccer, The probability he plays lacrosse is 48, which means he doesn't is 52. If the probability of a student playing soccer is 70%, then the probability he doesn't is 30%. Find the probability of a student playing lacrosse. All right, here we go. Playing lacrosse. 0.70 times 0.62 or 0.30 times 0.48. So we're coming down, this branch of the tree diagram right here, or this branch of the tree diagram right here. Those are the branches that are leading us to playing lacrosse. So that will be .578. So there's about a 58, almost 58% chance that a kid's going to play lacrosse. All right, you have two 9.3 assignments. And you are now prepared to do the first one and most of the second one. We have a couple more practice problems, like I said, to do that I didn't run off for some reason. So I will get those done, get those to you next time. So right now, your 9.3 number 1 homework is due. Your 9.3 number 1 will be due on Tuesday. All right, hope you're having a great day.